Hello, everyone. I am Abdelrahman Awad. That's how to pronounce my name. It's a little hard. I come from Egypt, and I don't live in a pyramid. So today, I will talk to you about how to build a SaaS application using Vue.js. So we'll cover a lot of problems that we faced and how we solved each one of them. In other words, I will talk to you about my full-time job. So Rasail is the app that we are building, / the company I'm working at. Rasail means messages in Arabic. So naturally, it's an inbox, right? So Rasail is an application that allows businesses to communicate with their customers through WhatsApp, whether their use case be sales, customer support, doesn't matter. But that means we have a fully featured real-time inbox, and that means messages coming in, conversations, agents having different views, real-time, lots of real-time, a lot of real-time, and data attributes. So it's a big thing, right? At the same time, businesses also need to have like a automation, right? Everything now is using AI and stuff like that. So that same application has a part where you can build an automatic flow that takes care of some conversations for you, assign agents, do some stuff with them, and assign them maybe to the right leads, stuff like that. So it's a big app. It's a really big app. And the ones that I didn't have a video for, but they are available right now, we also have campaigns, so everything in between. Contact manager, reporting dashboard, AI conversational toolkit, because everyone has AI now, right? And CRM integrations, permission role system, and much more. Again, it's a big app, right? So all of that is built with just 6 engineers, including myself. We are all from mixed backgrounds. I am with more front-end experience, the others maybe a little more back-end experience. So we had to start with a few bits. The first bit is in terms of technology choice. So the first bit is Vue.js. Why? Because we are experienced with Vue.js, and it's really easy to pick up for beginners, and it's really easy to learn from a back-end perspective. And if they are using another framework, it's really easy to switch to Vue. So it made sense to use Vue.js. Also, we are using TypeScript everywhere. There is none JS in our code base. There is 0 JS in our code base, just TypeScript. Why? Because we want everything to be type-checked. It's a large system. This large system interacts with each other. Each part interacts with the other. We need type-checking for that. And GraphQL. Why GraphQL? Because it's a mature system that integrates well into TypeScript and Vue.js. So, for example, we don't really need to set a lot of things up to generate types from a GraphQL schema, right? There are technologies now that do the same, so you can switch that for GraphQL if you want to, but it's not really a requirement. But for us, that means we needed to have an end-to-end typed system from the back-end communication layer back to the front-end. There is nothing that is not typed. Nobody can make something like nullable, and the CI will immediately explode. And we need that kind of type strictness because it's a large application. So what I really like about TypeScript in general is it encourages this mindset that anything that can go wrong will go wrong. If you have something that is nullable, it will be null at some point. If you have something that is possibly maybe assigned integer, at some point it will be a negative number. So that's what I really like about this code, and I think TypeScript said it, probably. I'm not sure who's the original. So let's dive right into it. Code structure, how does it work? So Rasail is not just the application that you just seen. Rasail also deploys to a mobile app, it deploys to an iframe app, and it deploys to the web. So we have multiple deployment targets. And that meant we needed a structure that represents that. And so we have like a mono repo kind of thing here. It's not a mono repo, it's just folders. But each has their own Vite config and TS config with very strict rules around each of them. For example, we have our shared module that has all the common components, the design system components, and so on. And the web and mobile can import from it. But they can't import from each other, and that's enforced through Vite and enforced through TS config. It won't resolve. And we needed to make sure that by fixing something in web, we break something in mobile. And if you have ever built something that works cross-platform, you will have experienced this case. Something as simple as making CSS height 100% can work on a desktop, but break on mobile. So there had to be some kind of separation. So let's talk about components. How do we organize them? We don't. So everything is one folder. It's a flat component structure. We have around 800 of them in web alone. I think total is around 1,000. But they are all Pascal case names. They're tightly coupled names, meaning everything has the same prefix. For example, the bot stuff has always bot flow action, bot flow node, bot flow message, bot flow something. And that makes them really easy to navigate and search for. So far, we don't have issues with it. And the order of words naturally is important as well. It's not really perfect, as you might expect, but it's not because the sheer number of components that we might have. It's because we have some discoveries that we want to improve on. For example, some components are system design components. They are our language, design language components. You don't really want them to be in the same place as the other components because you don't want someone to come in, change the margins, right? And suddenly everything changes across your app, right? These components need some special handling. They need some special care, right? Maybe even stricter CI, maybe even stricter kind of publishing system, maybe even requires a designer approval, right? So these components need to be separated somehow. So we didn't do that yet, but we are in the process of doing that. That includes stuff like form inputs. It's basically anything that you would expect from a UI library. Avatars, menu dialogues, and so on. Also, we have a few other components that can benefit from similar separation, like the bot stuff. It's not meant to be used anywhere else. We know that for a fact. And the reason we have like such a flat structure is because we don't want to waste time. Okay, what do I name this? What if it changed? Like it's used somewhere else now? Do I have to move it outside the folder it was in? And that wastes a lot of time. So we just create a component and that's it. But some separation might be useful in the future. Let's talk about composables. Oh, we don't follow the same rules here. They are nested, but we make heavy use of something called barrel files. If you are not familiar with them, barrel files are index.js, index.ts, index.whatever file that exports everything or combines everything inside that folder. We use it to make importing stuff from deep modules easier, but there are a couple of rules to make sure that you don't mess it up with barrel files. First, there is no side effects in barrels, meaning you shouldn't have functions, you shouldn't have assignments, you shouldn't have any weird things in there. Just export stuff. Why? Because you really don't want to mess up with the tree shakeability of your modules. If you add side effects, you may lose that. Also, there is no circular imports. Naturally, with an index.ts file, your editor VS Code will suggest you import anything from dot, right? Like if we have here, as you can see, the bot module, it has, let's say the manager needs to import something from the validator. It can import it through the index, or it can import it directly through the validator. You should always optimize to import from the validator, not the index, because now you created a circular dependency. Index exports manager, and manager imports from index. So it's really hard to enforce, but code reviews work, right? So let's talk about building those composables. So composables, in our case, are more of a, like, everything sandwich, where you have everything in them, almost, to manage a certain resource. In this example, I'm talking about conversation stream. A conversation stream is like the messages in a chat, right? The events, the actions, the things you see in a conversation. So their main job, composables, their main job is to maintain data integrity, meaning it fetches things from the API. It maintains their freshness through WebSockets, pulling, service events, whatever you want to use. It doesn't really matter, but it does that as well, and it uses browser events to make sure that data stays fresh. In the example I have here on the right, that's not really our code, that's just an example. We are watching for visibility change, and we are watching for online events. Those are DOM events, browser events. And we watch for them because browsers may decide to throttle your callbacks. And if that happens, you suddenly have a stale state. And in a real-time app, that's really bad, right? Imagine someone from a sales team talking to a customer from messages like, 5 minutes ago, that's disastrous. You can't afford to be one message late in that kind of business. So we make sure everything is fresh as long as they have internet, and that's good enough. Also, there is zero UI coupling. We have, like, our composables know nothing about our UI. If anything needs to know anything about the UI, it exists in the component. It doesn't exist in the composable. There are some exceptions, but we manage it through dependencies. Like you pass the element ref through the function parameters, and that's it. Now let's talk about state management. With Vue.js 3.0 and the composition API, it's really easy now, right? It's before it was you have to pull in Vuex, right? And now it's you just export something, right? And this is really great. Like this is like a minimal effort to set up. It's just one line, and it's typed. Like what's not to like, right? However, it has unpredictable mutability, meaning just as easy as any component can import this and use it, like in the second code window, any component can import it and change it. Not any component, anything can import it and change it. So there is also unclear ownership here, like who owns this? What is the source of truth here? It's obviously the variable, but who owns that? So we try a few things. First thing that comes to mind is the provide inject pattern. And if you plan to use provide inject, I implore you, use TypeScript. Don't consider otherwise. Because TypeScript has the injection key type in the Vue types, and the injection key type makes you type those injections. So it's critical for them to actually work in a, I would say, a company environment. Maybe if you are intending a library, you can skip that, but if you are working in a company, there is no way people have to hunt down your provides and see what's actually there. It's a really bad source of bugs if you don't have types. So make sure to do that. But with provide inject, it solves some of these problems. First, it's a top-down direction in the hierarchy. So the component that provided the thing owns the thing, and it provides it for the children. And it's a provider ownership, basically. So, however, it introduces a couple of issues. And I thought this was a better answer. Like 2 years ago, I thought this is like the answer to all of our problems. But it introduces a really bad question to your team. You basically traded some DX for this. The DX is which functions to avoid. What does that mean? Well, take a look at the code windows. Do you want your users or your fellow developers to use the inject, right? Because otherwise, they would create the context again, correct? However, it's really hard to use inject because they need to hunt down the keys. And it doesn't matter where you put them. Maybe you put them in one file, maybe you put them all over. It doesn't matter. They have to hunt down the injection and figure out if it is actually provided in that tree that they are working on or not. That's really hard. And that's why I saw most of our developers just call use current user. They thought that's the way to do it, but it's the way to provide it, not to use it. So that was a big problem for us. So maybe one pattern to solve this is let's forget about injections. Let's just use a singleton. And this is just good old global variable, set it to a value, and short-circuit it after, right? So it's a single instance. It's guaranteed to be a single instance. But it has a few issues. First issue is it's unclear direction. Where did the value come from? It's not top-down, that's for sure, because who owns that state now? The first component that calls it. And that's really dangerous, because imagine if you have a drop-down that uses this, that gets called before navigating to another route. Suddenly, that component is the owner of that state. And that means any tear-down lifecycle hooks, like component unmounted, or on before unmounted, sorry, or anything like that, is registered against that menu. It's not registered against the bigger, more important component. And let me put it in an example. Imagine the current user uses a subscription, a GraphQL subscription, real time. Typically, it would unsubscribe or disconnect when the component unmounts, right? So that will happen as soon as that menu disappears. And suddenly, you lost real time. So this is why ownership is so important, because it translates to the lifecycle hooks as well. How does this lifecycle hooks run, and which component do they run against? Another pattern that can solve this is self-inject. So instead of a global variable, we try to inject the key itself before we provide it. And that works really well. It's a top-down direction, it has provider ownership, and it has the implementation or injection details, meaning users need to just call use current user. And they don't have to worry about if this is in the tree or what the injection key is. The con of this is it may end up with multiple instances. If you are working in 2 different trees, so current user may actually do 2 HTTP calls, it's fine. But I would say make use of the 2 patterns. We make use of the singleton one for a state that will exist for the lifecycle of the entire app, like current user. This is for more contextual stuff. So you need to be careful about that. And if someone here is saying, why don't we use stores? Why don't you just use stores? They follow the same rules. Stores, I think, and I haven't checked in a while, use a similar thing to singletons. So if you have a teardown lifecycle hook, it will execute against that first component. Now let's talk about something more fun, performance. So that's our current scores right now for an Rasel is an SPA app. It's not on Next, sorry. It's not. So it's just a Vue app, right? And these are current scores for it. And a lot of people will say that's good for an SPA, right? Like it's a crutch or something like SPAs are not important to optimize for. But I think the current state of Core Web Vitals are really great at describing how the app behaves and how it translates to your users. For example, the cumulative layout shift measures the layout stability. And in inbox, this is critical. This is why this is the most important for us, actually. This is the most important metric for us, because you have an inbox with a lot of sidebars and a lot of stuff loading in, everything is lazy loaded, right? Imagine if all of these were jumping around. Imagine if they are scrolling through the stream and we loaded in an image and it jumps around. That's not a great experience. So that's why this is the most important thing for us. It depends on your application, of course, but another metric is the interaction to next paint. It was introduced recently. It replaced the first input delay, I think, and this is, I think, my favorite new metric here, because it measures the user journey as they are using the app, because the results are not reported on load, right? That means you can't actually measure this with Lighthouse. You have to collect it periodically from your users. So what I really like about this metric is it measures how long does a user interact with your app and how long does it take you to respond to it. So it measures responsibility really good. Then we have FCP and LCP, first contentful paint and largest contentful paint, and they are too volatile for us. Yes, they are really important, but they are too volatile because every user in our app has a different view than another user. A user may have a message stream full of images, another may have just text. So all of them, so the numbers are all over the place for these 2 metrics. So they are a bit unactionable for us, but there are ways to optimize for them. So I have compiled down a list of how to improve each one of these. So for CLS, because we did much more work in it than the others, so I will have a longer list here. So media ratio or size, images, videos, we did a lot of effort to make sure that we can predict the image height/width. And that actually happens by the backend. So whenever an image is sent, the backend analyzes it and stores its width and height. So whenever the front end needs to render them, it knows the width and height. And so it can calculate the aspect ratio, and then it can preserve a space for them, right? And this prevents the message stream from jumping, which is critical in such applications. We also have lazy elements. You need to be careful about those. As stuff loading around, maybe you are using suspense. When you switch from the fallback to the actual content, you need to make sure that doesn't cause a layout shift. You need to make sure both are stable. Other stuff like loading states, maybe you're pressing a button and a loading thing happens. Try to make sure it doesn't push anything around. It's a hard challenge, but these are all affect the CLS. There is also animation and transitions, so be careful about fading stuff in, moving top left, moving inset properties, moving margins, moving paddings. Be careful about these things. And then, unexpectedly, the scrollable elements can affect CLS, because let's say a user loads in 3 conversations, they won't have a scroll bar, right? But if they load in 100 messages, suddenly they have a scroll bar. And we suspect that's actually the reason why we have 0.04. Like a lot of users have that scroll bar pop in after load, so it causes a small layout shift. And lastly, async or synchronous persistence. Let's say you have a sidebar that is customizable. The user can resize it. They can move it back and forth depending on their needs, their screen size, and you persist that. If you persist it in IndexedDB, for example, which is asynchronous, it will take a small delay to read it. And that means there is a potential that the UI dances briefly as the value is being read. So for stuff like this, we make sure to only save those values in the synchronous persistence, like local storage. Let's talk about INP. Just respond to clicks. Easier said than done, I know. But it's critical that you do that. Examples for this are when someone submits a form, have a loading state, like disable stuff, do a paint, right? Have the UI react in a way. And this is why I really like INP, because it encourages you to tell the user what is happening. And yeah, that's almost all there is to it. Then you have another case that's really annoying and hard to deal with, which is lazy modules, right? Like with Vue Router, your pages are typically lazy, or lazy components. And the problem with this is, I'm sure all of us noticed it if you are using Vue Router. When you click a link for the first time, there is a small delay before it loads the next page in, right? And when that happens, that's affecting your INP score, because the user is waiting for something that's unclear for them. Now, solutions to this are really hard to implement. I think Max used to have, or still have, hot links, which when you hover, it preloads the module for them. And that will save you some time, unless the user clicks immediately. Then you didn't really save a lot of time. Another approach is people would wait for the user to be idle and start downloading stuff in the background. So that's a little harder to implement, but it's a solution. We didn't really do anything in that regard. And we still got a very good score. So I think you are safe for now. But anything else, make sure you respond to clicks, or more specifically, pointer events. So touches, or pointer up, pointer down, mouse up, these events. Let's talk about FCP and LCP. Just cache everything. Cache your assets, use aggressive caching, make use of the browser cache. These are all things we take for granted, because usually it's pre-configured for us on almost all of the platforms, right? But then there is also caching our data, or in other words, persisting our data. We think that will fix our scores for the FCP and LCP, because how do we fix something that's a little unpredictable, right? Like we can load in multiple images in the stream, we can load videos, so each user has a different number. But if we cache everything, or persist that last view, then it will solve that. But it introduces another problem. The problem it introduces is you just introduced stale data concept into a real-time application. So you need to communicate to the user somehow. If you have used WhatsApp or Messenger or any kind of messaging app, it loads immediately with your previous messages, even though if you are not connected, and it displays a loading state telling you, I'm still loading, I'm doing stuff here. What you are seeing is stale. And this is the challenge here for us. How do we tell the user that what you see is not something you should take an action on? You shouldn't do anything. And this is important because that's for customer support teams and for sales teams. He can't just repeat the same message expecting an answer, right? Like, it's more critical. So still data is more dangerous here. And so it's not a technical issue. It's a product issue. We need to think about how do we communicate that. So a little something I wanted to show is lazy loading balance. If you decide to lazy load something, there is a bit of a trade-off here. Here I am trying to load a component called command valid contact menu, and it needs to do a graphical request. But the total time here is much larger because there is a waterfall effect here, because we need to load in the JavaScript, the CSS, because it's a lazy component. Then, once that's parsed and run, it can now start doing the actual graphical request. So something that took a second could have potentially taken 600 milliseconds. If we try to at least try to load the graphical beforehand. So there isn't really a good solution for this. So try to balance it. It's like, don't spread your dynamic imports everywhere expecting your app to be better. Actually, it hurt us in a lot of cases. So and since we are an SPA, we don't really try to optimize for FCP or LCP, right? So that gives us some leeway here in ignoring this, or just loading stuff synchronously and not dynamically. One thing to know is Rasail is an app with a relatively long sessions. So what does that mean? I will leave you with a number and try to guess what does it describe. This is our current record of a user that didn't reload the app, 74 days. So that user probably, like for 2 months and 2 weeks, they didn't decide to reload their app once. And we know that because we have a Sentry issue with that exact version on our Sentry. So that brings a lot of problems. It brings asset version skew. Imagine if you have a simple server that builds the last build and serves them directly. So we have 2 users, each of them requesting a different version of the file. Imagine the first one being the 74 old days one, and the second one being you right now, for example. The first one will 404 because the asset no longer exists. The second one will 200, and that's a big problem. So one solution for this is we just keep the old artifacts. So we have a CDN that keeps everything. Every build exists there, and we periodically clean it up. And both will 200, ensuring that even if you are 2-month-old app, it still works. And this will occur a lot if you make a lot of use with dynamic loading or lazy loading stuff. You will have, I'm pretty sure, you will find some 404s in there. So surely this works really well, right? No, it doesn't work. Even with all of that, doesn't work really well. And this is a bit of an old issue, so you probably won't have noticed it with new apps. But if my PC builds the same file with the same content, it produces this hash. If your laptop builds the same file, it produces a different hash. Now, that doesn't happen with V3 onwards, but we used V2, so we need a solution for this. But then, because the hash used to rely on the machine. So each machine can build the same hash reliably, but different machines won't. So that means on the CI, every time we run it, it produces a different hash. And that means if you have a scaling app that have multiple servers, each one has its own hash because it's built on a different machine. And if that happens, most of your users are 404ing because the load balancer keeps redirecting them to different servers. So we needed to make this more consistent, and we did that with a commit hash. So we just configured Vite to get the short commit hash and append it to the file and use it as a hash, and it works really well. We even put it in folders inside our CDN, so it works fine. Let's talk about something else, the API version skew, which is produced by the same thing. OK, what does that mean? It means your app is now talking to a new backend because the user didn't reload in 74 days. So is it still compatible? That's a big question here. And many providers just reload the app. I really don't like that because it interrupts the user experience. What if they are putting in a really important message and you just try to reload it, right? That's not a great experience. Another issue is your front end is actually the new one, and it's talking to an older backend because the backend didn't finish deploying it. So there is a chance that this happens. And this means your front end might be requesting a field that doesn't exist yet, and it will crash. So how do we solve this? Well, we version our app, but with the commit hash as well. And this, we can call it a pre-release version. It's kind of in the semantic release kind of things, but we also put it in the backend as a header. So the backend tells you, I'm expecting this front end to communicate with me. And whenever a change happens, we make sure first to detect that, parse the built version, so that's a static value, and parse the API header. And this happens in every single network request, because we ship like crazy. We ship like, I don't know, maybe 12 PRs in one day, so that means 12 different versions every day. And that means we need to break down the version difference. So if a pre-release changes, it's just a new commit, nothing changed, so nothing to worry about. If a patch, we need to soft prompt it. If a minor, we need a stronger prompt. And if a major change happens, we need to actually block the app users, because it will crash at some point. So what does the prompts look like? Something like this. If a patch version happens, this is what we show to the user. If a major change happens, this is what we show to the minor change, sorry, happens. This is what we show to the user. And if a major change happens, we just block the entire app and tell them, you got to reload. Like, you are way beyond what we expect right now. And it's actually pretty useful to track issues by the release, because it's now baked in, and it's not on a CI, so it's not adding commits, so it's a little bit softer. We may make use of change sets in the future, but that's still under investigation. We are not sure if this works well for us or not. It doesn't work with Sentry well, because Sentry recognizes this as a non-semantic version when it actually is, but it works well for us. Maybe next year, if I do this talk again, this will be a little different. That's all. Thank you. And yeah, that's all.